Hello, everyone. Palletizing robots are widely applied in the palletizing industry. These robots significantly save labor and space, while offering flexibility, precision, speed, efficiency, and stability during operations. In previous lessons, we learned about several typical applications of industrial robots. In this session, we will study case studies of different forms of palletizing. This class will focus on the following aspects: the composition of palletizing workstation systems, design of spatial motion trajectories for palletizing, calculation of teaching points for palletizing, and process of robotic palletizing. First, let's learn about composition of palletizing workstation system. The robotic palletizing workstation system consists of several components: the robotic body, handling tools, gripper or suction cup, control cabinet, and palletizing workbench. Next, let's move on to design of spatial motion trajectories for palletizing. Block handling and palletizing. The robot transports a workpiece from the left side station to the right side workstation. After grabbing at a fixed position, the robot moves the workpiece to the workstation for palletizing in a T-shape pattern, placing 4 blocks in 4 designated positions. Characteristics of robotic palletizing. Robots can execute rapid, orderly handling and palletizing tasks. How can the robot complete the palletizing task for specified workpieces? First, determine the number of handling positions, the number of palletizing positions, and the number of teaching points. Once these numbers are known, fast and efficient teaching programming can be implemented, allowing the robot to perform the required palletizing operations. Next, let's learn about calculation of teaching points for palletizing. Palletizing is performed in a T-and matrix pattern. In the workpiece coordinate system, the first placement point is the reference point, while other placement points are calculated through positional offsets. In the workpiece coordinate system, the first placement point serves as the reference point, and the other placement points are calculated using positional offsets. The palletizing rule involves transporting workpieces from handling positions and sequentially placing them at the designated positions based on the teaching points positions. Let n represent the numerical variable corresponding to the count of palletized workpieces, with an initial value of n equals 0. After each workpiece is palletized, n is incremented by 1, n equals n plus 1. If the first palletizing position is selected as the reference point, the n plus 1's workpiece's placement point is determined through positional offset calculations. Important notes for programming. Once the reference point is established during the first teaching process, its parameters cannot be modified. Therefore, it is essential to mark the reference point after the initial teaching to ensure that it does not change during program execution. Let's continue learning about analysis of robotic palletizing process. The main process of robotic palletizing is as follows. The system first performs initialization, and the robot returns to the origin. The robot moves to above the handling position, set reference point 1. The robot moves to the handling position, set reference point 2. The gripper picks up the workpiece, introduce a delay or check whether the workpiece has been successfully grabbed. The robot carries the workpiece to reference point 1. The robot moves to the palletizing position, reference point 3. The gripper opens to release and palletize the workpiece, introduce a delay. The robot moves back to above the handling position at reference point 1, and this process repeats for the next handling and palletizing cycle. There are multiple methods for setting handling and palletizing reference points. They can be set individually at a single position, or offsets can be applied using the configured reference points. You can choose the appropriate method based on your proficiency level. There are other methods and case studies in palletizing as well. For example, the for loop can be used to repeatedly execute conditional instructions. The for loop is suitable for situations where one or multiple instructions need to be executed multiple times. The form and position of palletizing can also be defined independently. However, it is crucial to pay attention to the setting of reference points during this process. Setting reference points must be accurate and meticulous. This also reminds us to maintain this spirit of precision and diligence both in learning and in our future work. The 2022 Great Country Craftsman Person of the Year, Jing Weidong, mentoring the transport robot, is an excellent example of this learning mindset. In this lesson, we studied the composition of the robotic handling workstation. Using the example of block handling and palletizing, we analyzed the design of spatial motion trajectory during the process of robotic handling and palletizing. We also calculated the teaching points based on the palletizing patterns and analyzed the robotic process. Robotic handling and palletizing is one of the typical tasks of a robot. By analyzing the characteristics of palletizing and selecting an appropriate method for teaching point calculations, the on-site debugging time for robots can be significantly reduced. That concludes the lesson for today. Okay, see you next time.